Okay, in this video we're going to do a quick revision of how to do matrix operations. Now for us, the main reason, well, the only reason we use matrix operations in our course is to do transformations with graphs. And even then, you can use mapping instead. So check out those videos on mapping versus matrices. However, you do need to recognize the matrix equations and how to use them, because they do come up in exams regularly with matrices. So let's remind ourselves some basic operations that you need to know to do this. To add or subtract matrices, you must have the same dimensions for each matrix. So remember, dimensions are the number of rows by the number of columns. So look at this first one here. This would be a 2 by 2 matrix. There's 2 there, 2 there. So I'd call this thing a 2 by 2 matrix. This one has 2 rows, 2 columns, so I'd call this a 2 by 2 matrix. Given that both of these here are the same, we can add those 2 matrices, or we could subtract them or put a minus there instead. That's fine. However, I could not do this second pair because that one is a 2 by 2, but this one has 2 rows by 1 column. So it's always rows by column, and there's different number of columns in this case, so I could not add these 2 together. Now, the reason it's so important that you have the same dimensions is because you add the corresponding elements together. So what I mean by that is this top left-hand corner must add to that top left-hand corner. The top right must add to top right. Bottom left must add bottom left, and then bottom right must add bottom right. But if I have this other case over here, you might be able to add those 2 together. You might be able to add these 2 together. But then what is left to add to this one or this one? Well, there's nothing sitting out here. Okay, so you cannot add 2 different matrices together if they do not have the same rows and columns. All right, now to add them together, we do just add together the corresponding elements. So in this case, we're going to look at the top left-hand corner of each one. So we're going to do 2 plus 3. And that stays in the top left-hand corner of the final matrix. We're going to do 3 plus a negative 1. Stays bottom left. 0 plus 9. And then 4 plus 2. And it all stays in the same positioning. So 2 plus 3 is 5. 0 plus 9 is 9. 3 plus a negative 1 is 2. And 4 plus 2 is 6. And that's how you add a matrix. Let's do a couple others. Let's check this one quickly. We have 1, 2, 3 rows, 1 column, so 3 by 1. 1, 2, 3 rows, 1 column. That works just fine. So now our final matrix, we're going to do negative 2 minus a negative 3 because they are in the same position. The 4 and the 2 are in the same position, so 4 minus 2. And the 5 and the 9 are in the same position, so 5 minus 9. And then we simplify. So that becomes plus, of course, so we get 1, 2, negative 4. And last one, we can add and subtract multiple matrices. And look at each one. They each have 2 columns. They each have 2 rows, 1, 2 rows, 1, 2 rows, 1, 2 rows. And they each have 1, 2, 3 columns. So they're all 2 by 3 matrices. So I'm going to make sure I add these ones together, and they're going to stay top left-hand corner. These ones together, they stay top in the middle. These ones, they stay top right. These ones, the result stays bottom left. These ones remain bottom middle. And then these ones remain bottom right. I don't know how I missed that one there. Okay, so let's do that. So we get 2 plus the negative 3, take away 9. We get 4 plus the negative 1 minus the 6. We get 1 plus 5 minus 7. We get negative 3 plus a negative 2 minus a negative 3. And then we get in the final column 0 plus 4, take 2, 8 plus 1 minus 8. Altogether, do not forget to put your matrices the matrix notation at the end, otherwise you've got a bunch of random numbers. And then from there we simplify. So 2 plus a negative 3 is 2 minus 3 is negative 1. Take away 9 is negative 10. 4 plus the negative 1 gives you 3. Take 6 is negative 3. Put out matrices before I forget. 1 plus 5 is 6. Take away 7 gives you negative 1. That's 3 plus a negative 2 gives you 1. Add 3 more gives you 4 because the two negatives make a positive. 0 plus 4 minus 2 is 2. 8 minus 8 is 0, so you get 1 there. And that is how you add and subtract matrices. However, when you multiply matrices, you treat it differently. You don't check the same number of rows and columns, although if you've got the same number of rows and columns, in a square version, it will work. It does not follow the same pattern when you're doing multiplying. Essentially, the second one, you kind of need to turn it on its side as such. You want to turn it a little bit differently. You want to make sure it lines up nicely when you turn it on its side. So what I mean is, in this one here, we've got 2 rows and 3 columns. This one has 3 rows and 2 columns. The important part is that this middle number, this number here and this number here match. Okay, so the number of columns in this one, so 1, 2, 3 columns, matches the number of rows in the second one, 1, 2, 3 rows. That is really important. So as long as that matches, we're good. And like I said, if you turn this second one on its side, you'd end up with 3 columns, which matches the 3 columns you got there. Now, when you're multiplying them, you multiply by moving across a row and down a column. And once you finish that, you then move across one column, go across the same row and down the next column. Okay, so let's see how it all works out. Oh, and I should say the resulting matrix, the final matrix, will be, remember, a 2 by 2. So if the middle numbers need to match, but the outside ones will give you the final result. And that's what I said in this last step here. Whoops, I said the wrong thing down here. This should actually say M by Q will be your final dimensions. I do not know how I did that wrong. N and P must match to multiply. And let's have a go at this one here. So we're going to move across the row, down the column. We have a 2 by 2, 2 by 1. That middle number does indeed match. We're expecting at the end a 2 by 1 matrix. So let's see what happens. So 3 times by negative 4. So we do the top one here, top one there. And then we move across one and move down one. We move now to do 2 times 1. And you add those results together. There's no more rows to go down here, no more columns to go across there. We've gone all the way across and all the way down. So now we repeat the process, but we use this row instead. So we start at the 4 and move across, and then the 4 and move down. So it's 4 times negative 4. Then we move across the row to the 3, so plus 3. And the 3 is now multiplying the 1 because you move down the column. And then we simplify those. So 3 times negative 4 is negative 12, plus 2 is negative 10, 4 times negative 4 is negative 16, plus 3 is negative 13. And hey, we've got a 2 by 1 matrix. Right, next one. Same idea. Let's check. We've got 2 rows in this one, 1, 2, 3 columns, 1, 2, 3. And here I've got a 2 by 2 matrix, which doesn't work. So we couldn't multiply this together. So to make sure we can multiply them together, I am going to extend this out a little bit more and make it a 3 by 2. Let's just do a simple one with some fairly straightforward numbers. So now I get 3 by 2 here. So the middle ones now match. And our final matrix is going to be a 2 by 2 matrix. That's what we should end up with. So let's see what happens. We're going to start top left corner of each one, and we're going to move across this row, multiplying as we go down this column. So 3 times negative 1, plus, now we move on to the negative 2, and the 1. So plus negative 2 times 1. Plus, we're going to move across again, 0 times the 1. Now we had first row, first column. The result goes in the first row and the first column of the resulting matrix. Now I leave a space and I move on to the second column. So first row, second column I'm now going to deal with. So instead of dealing with the first column, I'm going to do this one and this one now. And move down that as we multiply. So moving from negative 3 times 0 plus negative 2, move down to 1, negative 2 times 1, plus the 0 times 2. So if you notice, I've now finished both of these columns with the first row. So I now move down to the next row. So I'm going to get a -1 there and back to start the -1 here. So I'm going to go across this row and down that column now. So -1 times -1. Again, second row, first column. So this is our second row. Our first column is when the result is going to be. We add it to the 3 here by the 1 there, so 3 by 1, plus the 5 here by the 1 there. We leave it a space, and now we're going to have our last combination. We're going to have second row, second column. So we do -1 times 0 plus 3. We're going to move down to 1, 3 times 1, plus, and move across to the 5, down to the 2, 5 times 2. And then we simplify all that. So it's a matter of arithmetic now. So -3, -2 together give you -5. +1 plus 3 is 4, 9. 0, -2, 0, 3, 13. That's multiplying matrices. Note I haven't talked about dividing. It's because we don't divide matrices. We do something called multiplying by its inverse. That's for a different video another time. That's not part of our course at the moment. So you don't need to worry about that. So we only multiply and add, subtract matrices at the moment. The last thing I want to remind you is how to use it in terms of a bit of transformations. There's a different video about transformations, but this is the kind of context we'll need to do it in. You need to remember your BODMAS rules to do your transformations correctly. So here, I'm going to multiply this out according to BODMAS and have it fully simplified. So first check, I've got multiplication is happening first. So I've got 2 by 2 matrix there, 2 by 1. So the resulting one should be a 2 by 1 matrix. Which, look, this is a 2 by 1 matrix then. So I can multiply this first one out and then I can add that together. So let's do that. We know how to multiply things out, and I've deliberately chosen zeros in those corners because that's how we're going to see it with our transformations. So you get 2 times x plus 0 times y, which of course we know just gives you 2x. And then we move down a row to the first column again, so 0 times x and -3 times y. Goes there like that, plus your -4 and 1. Now here the 0y disappears and we have a 2 by 1 matrix and a 2 by 1 matrix we add together. So this becomes 2x, this top row adding a -4 there, and the bottom row the 0x disappears, you get -3y plus 1. There are 2 terms in each row there, but there's still 1 row, 1 column. If there's a big gap like up here, big space between them, that makes them different columns, but it is a symbol, a mathematical symbol joining them, they're 1 column. Now that one differs a little bit to the one over here because over here notice there's brackets. So the brackets come first. So this matrix for multiplying at the front is going to have to be waiting for a minute. So I first combine, these are 2 by 1 matrices together. So you get x plus 1, add the top and the top, and you add the bottom and the bottom. So y minus 6. This is a 2 by 1 matrix. Again, there's 2 terms, but still a single column because they're combined by a mathematical symbol. 2 times 2 there. The middle ones match, the 2's match, and the resulting is going to be 2 by 1, which is good. And we multiply out. So it's -2 times by the top row plus 0 times by the bottom one. So moving across and down. This first row is now exhausted. We go to the bottom one. So now it's 0 times by x plus 1, back to the top and down, plus 1/3 y takes 6. And then we simplify. So you end up with -2 x plus 1 and 1/3 y plus 6, which you could expand out if you wanted, but we're going to leave it there for this point. And that is how you perform basic operations with matrices.